Thank you very much, Chris. Very embarrassing to hear you, but I've known Chris for many, many years. I can't remember how many, and I'd like to say that I'm delighted to be here. Looking around the room and listening to you yesterday and talking to several of you, I think this is going to be one of the most interesting meetings we have attended in a long time. There are lots of you that I would like to spend hours talking to, so I'm very excited about participating. Chris had asked me to do a keynote, which I think is a rather pretentious thing with a group like this, so it's not going to be a keynote, never was, and I'm not going to use all my time. That could be used favorably in other ways. And I've also changed what I was going to talk about, largely as a result of some plastic interactions yesterday evening, in good part of the conversation that I was having with Dario Gil at dinner, and that has to do with something very integral to the topic. I think that when you talk about superhumans, of course, there are numerous areas that we can talk about: moral enhancement, the area of prosthetics, which I think is a rather non-controversial area, and especially when it comes to a mechanical prosthesis, is not only here with us, but will be extremely useful for obvious reasons. Anyone that has lost a mechanical component, for example, in locomotion or in hand motion, will be delighted to know there will be possibilities of compensation for such deficits. And then there are other areas that are considerably controversial and will be. Anything that has to do with synthetic biology is a reality today, but I think is going to be extremely problematic in many ways. We can discuss those in just a minute. But there's one area that interests me very much, which has to do with human-like robots. And I have been struck by the fact that what I think, and let me start by saying, and I'm not an expert at all in that area, I'm learning, but it strikes me that there's something odd about the way people have gone about constructing such creatures. And basically, that oddity mimics the way in which we humans have gone about studying how the human brain and mind operate. If you look at the history of neuroscience, and the history of neuroscience and psychology are confounded when you really started in earnest in the 19th century, what you find that is very odd is that you start at the top, exactly the same way that you start when you deal with artificial intelligence. What did we study first? If you look in history, we studied language. Can you imagine? We are creatures that have as the fundamental problem biological regulation. What we are about primarily is having a living body, which is an extremely complex entity, and we are fundamentally about staying alive. We are about maintaining the health and integrity of an organism for a certain period which is allotted in good part by our genes, in good part by luck in the interactions we have with the world, and language is certainly not the primary problem. Language, cognition in general, our intelligence, our memory, imagination, the way we reason, the way we perceive, have been apps that have been added on to this interesting organism over eons of evolution. But it didn't start that way. It started in a very simple way, trying to maintain life. What is interesting is that all those apps aim at exactly the same problem, which is maintaining life in the most optimal circumstances in situations which have become very, very complex and which, of course, require a ton of intelligence in order to solve the problems. But so, going back to history, we have studies of language. In the middle of the 19th century, this was the rave. All of you know about Paul Broca and Carl Wernicke and their discoveries about areas of the left cerebral hemisphere, which process language. And so to begin there is extremely strange. Then studies that involved reasoning and perception came along, then memory, and only at a very late stage do you get studies on, guess what, emotion, and social behavior. Well, it turns out that emotion and social behavior are part of that primary set of skills that our organisms have and have had, and which, by the way, organisms have had even before they had brains. So the first thing that I would like to ask you to think about is that this issue of life regulation, let's say it begins with single-cell organisms. And with single-cell organisms that may not have a brain. In fact, in many cases don't. So you have an organ, there's a membrane, there's something equivalent to our skin. There's something, for example, in several of these creatures that is equivalent to our locomotion. They can displace themselves in an environment. There's a nucleus, and there are a lot of organelles in the cytoplasm, and this is basically the model that we carry now. What we have now is these appendages, legs and arms, and a head that moves, but fundamentally is the same thing. These creatures don't have brains, and yet, when you observe their behavior, you can identify things that will look to you like joy, relaxation, anger, fear, retraction, running away from predators, and you even have social behavior represented in the following form. If you have single-cell organisms that are in a given environment where there is plenty of confidence in terms of nutrients and lack of predation, those organisms adopt an independent position and can separate. If suddenly there's predation or there is scarcity of nutrients, those organisms aggregate and create clumps. And you have very beautiful model, a very beautiful primary model of what social behavior is all alike. But just think of it. This is happening in living organisms that don't have brains yet. So my contention, and I've written a bit about this, and this is actually what I'm most interested in at the moment, my contention is that what our brains became is a projection of very fundamental principles that are already available in single-cell organisms and that are available in large part in the interactions of the nucleus of the cell and of the cytoplasm, and that then become extremely complex with the development of progressively more elaborate means of perceiving the environment, interacting with the environment, and of course interacting through means of communication with other creatures. So one thing that I've been interested in, I've now asked this from a number of people that I respect in terms of their thinking, and I asked this from Dario last night. What about building creatures that are human-like? And that would be, for example, very useful in terms of having them help other human beings when other human beings are not present. How about building them from the inside out? And building them with something that would be equivalent to this principle of life regulation, which, by the way, goes by one word only, and that is homeostasis. This ability, we could call it also homeodynamics, this ability of maintaining the integrity of the organism and dealing with procurement of energy, dealing with desire and sex so that there's procreation, dealing with defense, dealing with the integrity of the organism, which really means integrity in relation to disease in the organism as well as integrity in terms of defense from attacks, and dealing with social behavior. So what about building creatures that would have some of these principles incorporated and where cognition would first and foremost relate to those internal principles and have a way of regulating that stability of the organism, and then go on to connect with the outside world. So literally turning the story upside down. So this is really a question for you, and if you would want to give me feedback on this, I would be very grateful. I have a graduate student who was infected with my ideas about this and who is now committed to building such creatures. So I need to guide him and the team. So I would like to hear what you think about that. I can tell you that Hannah has lots of objections about this, but I hope that she doesn't tell you what the objections are, because I think they're very smart, and I would rather have you discover them first, or not discover them. That would be even better. This is one of the first topics that I would like to touch on. Can I ask for comments at this point, or not? Does anybody want to react to this? Just tell me to sit down, and you have been smiling.
And introduce yourself.
Can't hear you.
Okay. Paul Howard-Jones from the University of Bristol. I'm just interested, I mean, I don't think I have any doubt that the inside-out approach is possibly radical and the most likely to possibly to be the most effective way of developing such a robot. I think what worries me is the possible conflicts that might arise, or the moral issues that might arise, with developing a piece of technology that has as its primary principle the maintenance of the integrity of its own systems. I can see there being a fundamental conflict with the idea that the technology is there to serve people.
Yeah, I think I can see that, but I would be happy to pay that price if the result would be a more effective and more human-like creature that would have interactions that would be truly more intelligent, as opposed to having a cognition that was totally inserted from the top and that is in no way related to the basic internal dictates of the machine. So, but I take your point. Other comments?
Mark Frankel from AAAS. The word creature is loaded. Mm-hmm. Why do you insist on referring to these entities as creatures, which sends a signal to the larger public, of course, that this is something to be very concerned about? Why have you chosen to call them creatures?
I didn't. It just came out. It was involuntary. But I take your point. I think it's probably not a bad idea to. So you would not want creature. Would you go with organism? Or do you think it's equally loaded?
No, I would find that more
tolerable.
More tolerable.
Very good. Fine. Off with creatures, in with organism, devices. Yeah, I think that's a very good point.
I think you'd be better off calling them personal digital assistants.
The personal is very loaded. Be careful. Yeah. Any other comments? Okay. Well, I hope we will come back to this if we have the opportunity. Now, I think that allows me to connect with another topic that. And that was part of what I wanted to tell you today, and that has to do, in fact, what you just said is extremely important for the connection, because it has to do with the meaning of certain words and the potential meaning of certain interventions and the kind of reactions that one could expect in relation to them. The good background for this is what one can call the two cultures debate. And I have been interested in this problem because, as some of you may know, there was in the early 1960s a very famous debate that went by the name of two cultures. This was the result of an essay that was written by C.P. Snow, who was an interesting physicist, novelist, and public intellectual before the word public intellectual the term was known. And C.P. Snow first gave a lecture at Cambridge, which was followed by a book published in 1964 that became an almost instant success and bestseller. And what C.P. Snow was talking about was the fact that there were two very clear cultures available, even if there were different subspecialties within the cultures. And there were the culture of what he called the literary intellectuals and the culture of the scientists. And the scientists were not pure science in any way, it was scientists and the offshoot into technology that came from the sciences. And what C.P. Snow identified and was bemoaning was the fact that these two cultures were, first of all, not in balance anymore. It was obvious that the sciences were dominating and the technology was dominating, and that this was probably going to be enhanced and get worse with time, and that the cultures were no longer talking to each other. And this was the thing that he was most worried about. And this was actually quite interesting because when Snow first gave his Reed lecture at Cambridge, the science and the technology that he had in mind was physics, and the offshoot into electronics and into atomic energy and, of course, atomic weapons. And he was very worried about that. By the time he wrote the 1964 book, only 5 years later, he had switched and he had gone to biology. And it's actually quite interesting that he prophetically said, I'm no longer talking about the second law of thermodynamics, I am going to be talking about the results of the discovery of the DNA molecule and the impact that this is going to have in the life of individuals, and this will change in a way that is even greater than what Darwin has already changed. And of course, he was completely right. This is exactly what has happened. And today, although there's justifiable concerns, for example, around atomic energy, there's the big story is a story that has to do with biology and with all the offshoots that come from the Crick and Watson discovery in the 50s, and human genome and so on. So I think that's very interesting. The other thing that is interesting is that if you look at the panorama of the cultures today, it is still exactly as what C.P. Snow described. So there are now much more varieties of arts and hybrids of arts, but the humanities and arts continue to be the same group. So you have arts, you have history, you have philosophy, the world of reflection on what is going on in science and technology, and a variety of literary production, literary intellectualism, and then you have the world of sciences and technologies. And depending on where you are, it may appear that this is in balance and in consonance, or that this is in a very, very big rift. So, for example, in leading universities, you have a side, depending on the structure of the university, some universities have made an enormous effort of integration, and some universities have not. In some, there's clearly a disparity, and there's actual complaint and reaction, especially on the side of the arts and humanities. And in the public, it depends on where you are, it depends on the age groups, but I think it would be very foolish if we would ignore the fact that there are these rifts out there, and that depending on the group that you're dealing with and on the issue that you're dealing with, you may get an enormous amount of reaction. And I find that reaction perfectly understandable, and I think we need to compute that. And I think one aspect that is very interesting actually has to do with some work that we're doing now at the Brain Creativity Institute at USC. It actually happens to be funded by DARPA, and has to do with the notion of sacred values. Now, if I say the word sacred, for many of you this will mean necessarily a religious value, but in fact, sacred simply refers to, in this research, to a non-negotiable item. And there are all sorts of things that are sacred naturally for many of us, such as life, moral values, for some of us religious principles. And then there are many things that become sacred by dint of the culture in which we live in. So, for example, land is a very sacred value if you go to Israel and to the Palestinian territories. Land can be sacred in other territories as well, but for example, the clear and clean water can be a sacred value, and clean air can be a sacred value, and atomic energy can be a sacred value. So we live in a world where it is, has become quite obvious that certain things under entirely cultural influence become sacred. And if they're sacred, if something becomes sacred, then that thing is no longer negotiable. And that's where you stop. And it's very interesting because in the studies that we have been doing, which are cross-cultural, there are certain things that people will say, there's no amount of money that you can give me that will make me change my position. And this is something that we need to know and that we need to deal with. So when you see, for example, the appearance of, for example, synthetic biology applications, keep in mind that this reaction is likely to be extremely strong, and I think we better keep that in mind. And the same way, by the way, and of course, I don't think any of this will apply to prosthetics. I think people will, on the contrary, embrace that and are embracing that, but you go to synthetic biology and it's another story. There's something that connects with this, which is the fact that, for example, with synthetic biology, there are risks that have to do with criminal behavior that I think that in a world where we see the amount of web crime that we're seeing today need to be taken very carefully into account, especially when you think about the possibility of synthesizing molecules that are dangerous. For example, having a synthetic smallpox virus is something that needs to be very seriously considered. And if it's there to be made, it will be made by somebody who should not be making it and who should not be using it. So those are things to keep in mind in relation to that problem. And this reminds me of one other little story. I think that many of you have heard and probably will be talking about something that has been known by the term moral enhancement. It's another story that gets people extremely upset and has to do with the use of a chemical molecule to treat what may be criminal behavior, predictable or known criminal behavior. And this, on the face of it, is a sort of invasion of human life. On the face of it, it is, on another view, it is not. And it is not because there is no question that, for example, if you have from the relatively small proportion of people in humanity that have the great potential of behaving criminally, and it's a very small number, and it's a relatively identifiable set of individuals. Those individuals, once they commit crimes, those crimes have a huge cost to society and have a huge cost to themselves, to the perpetrators, because they are going to be dealt with in a rather radical way that can range from the radical immediate, like killing, or to the radical protracted, such as life imprisonment. Against this background, the idea that a perfectly well-designed molecule could induce a change of behavior that would not be costly, it would not be to that individual, and it would make society safer, seems to be a perfectly reasonable cost. I don't find this objectionable in principle if it can be done properly, but lots of people will. So this is something that is coming into our prospects, and I think we should consider it very carefully. But of course, none of these considerations can be undertaken separately from this reality, which is the reality of these cultures that are appearing. And I would like to close with one other idea, And that is, sort of goes back to the beginning, to the idea of why is it that we, as human beings, evolved the way we did, and what is the root of the things we do with our cognition, the things we're doing in this room today, for example. And I think that they are extremely, first of all, they are rooted in principles of homeostasis. I think it's an idea that I think is perfectly reasonable to defend. But what is so interesting is that they are exactly the same forces that have led humans for a good part of historical existence to create the arts and eventually the humanities, and those same sets of reasons led to the creation of sciences and technology eventually. It simply has to do with the difference in historical times. So humans began, the way we're designed, I would say that we have created all these cultural instruments as a way of responding to the particulars of the human condition. And so you should ask me, what on earth do you mean by the human condition? And what I mean by the human condition is a set of designs in our machine. I hope you don't object to my using machine for this human creature. There they are, and they oblige us to do certain things on certain occasions, certain things in relation to certain stimuli from the environment. And they are the givens of our drives and motivations and emotional designs, which are extremely comparable, in fact, in many ways equal to lots of other mammals and birds and species below us. So that's the basic. Then something else came which really gives rise to culture, which is the extraordinary development of perception, the extraordinary development of memory capacity, and the potential for imagination. You see, once you only had perception of the environment and you dealt better with the responses to the environment, that was fine. But once you have perception and memory, and you have the possibility of imagining other worlds, you start doing what we're doing in this room today, which is imagining other worlds, imagining possibilities, and trying to incorporate those possibilities in our plans of life. Once that happens, then you have the possibility, which is both a tragedy and a blessing, of asking questions and creating answers. And one of the first questions that humans asked, obviously, had to do with issues of who are we, how did we come about, why are we here, and what is our destiny? And these were questions that must have been extremely powerful for individuals that before us were, for example, living in a cave, but still had to do with issues of defense and maintaining life, and had to do with issues of coalition and linkage to other humans. We are naturally linked to other humans, and we would be linked to other humans by affect, by love, by all sorts of dedications. Those dedications could be lots of fun if you're talking about desire and sex, but they could be very tragic when you're dealing with death. How do you explain death? So I think that the development of religious beliefs, the development of organizations that have to do with politics, economics, justice, moral behavior, all came about in an environment in which we were responding intelligently, the way current artificial intelligence is designed, to things that are very intelligent but were not designed by us, are part of our basic organisms. And eventually, once we have the possibility of creating hypotheses and theory and experimenting and doing tests that allow us to verify if our hypotheses are correct or incorrect, and we have data, then we do another kind of excavation that is called science. And out of that then can come technology, which is very well represented around this table today. But the long and the short of it, as far as I can see, is that this is the same impulse. There is nothing in these two sets of cultures, whether it is the humanities and arts or the science and technology, that is fundamentally different in terms of its humane and human source. And so it stands to reason that the cultures ought to be together, but of course they're not for reasons that are social, economic, and political, but we have to cope with that if we're going to cope with the institution and the progress in an area which is very intriguing and is obviously here with us in some part, which is the superhumans. Okay? Thank you very much for your attention, and I want to hear more of your impressions. Thank you.
Thank you.